processes, so many formulas, and we are going to lay the foundation in the two laws of thermodynamics. And today's lecture is all about the first law and the different processes. With me, your captain Shreyas, going live at Vedantu. Hi Ramya, Light, Saja, Dakshin, Suchi, Rohan, Light, Nandini. Welcome Vela, welcome P. Arvin, welcome Vaishal. Hello Tech. Nice to see all of you lined up, waiting. And I see all these students every now and then. It makes me go really happy, makes me feel proud. I'm really proud of all of you because you wait for me, and so many of you already shower your love by smashing the like button even before the session starts. It shows your immense faith and your dedication towards studies. Thank you so much. Yuva, hello Shalem, hello Kalai, hi Rishita, good evening Shri, hello, nice to see all of you. And what are we going to study in today's class? Let's have a quick look at it. Heat, work, internal energy, the basic formulas, sign conventions, and also what is the meaning of state functions, systems, path functions, first law and its application, cyclic processes. We are going to have an overview of it. There is a dedicated lecture on cyclic process and the second law with heat engines and refrigeration. That's going to happen next time. And types of thermodynamic processes and free expansion, of course, along with polytrophic process. All of this with your favorite. Welcome aboard. This is your Capto, your navigator, your master teacher. Thank you so much. How many PYQs should you solve for mains along with the sprint? Well, I would suggest you to solve at least last 10 years. 10 years PYQs are must. Yes, this is the first lecture, Tharshan, on thermodynamics. Hi Bhanu Prakash. Nice to see you back, Vaishal. Hello Stark DJ. Welcome. Nice to see. Nice names you guys got. Light Yagami. Wow, what a nice name. Josh is also hi, says Ankit. Very good. Thank you, Srinivasa. And welcome aboard. Welcome aboard. And you guys have really come till this point. And we started the Pathfinder series almost like April or May last year, 2021. And you are here. That means you guys are like Pushpa. मैं झुकेगा नहीं है ना. You guys are like Pushpa. I'm not going to bow down. I'm not going to give up. And if you guys are not going to give up, please let me know in the chat box and say मैं झुकेगा नहीं. Or I don't know how is it said in Telugu. How Alu Arjun says it in Telugu. It's really cool, right? The way he says it, legendary. Yep. Let's get going. Yes. Our language movie. I saw it. And I saw it with subtitles. I loved that movie, the way Alu Arjun is, and the way they also get in Chiranjeevi in that movie. It's really fascinating, it's crazy. Yay, there we go. Yep, let's get going. Who's Pushpa? Okay, Pushpa is a very famous character, the legendary role played by Alu Arjun. You should watch that movie maybe sometime later in case you don't have time. All right, so also let me tell you, if you want to gear up and speeden up your process of preparation, then we have the dedicated JEE crash course for mains plus advanced with 90 sessions recorded plus live, PDF notes, test series, assignments, lots of things for you, and not just that, there are the best master teachers who have a proven track record of getting very good results. And the best part is these mock tests are designed year over year, they're different, and they will ensure that you get the right kind of questions just before the mains. So go ahead, check it out. There is a Republic Day offer which is going on, and you get 50% off on the price. That means you will get 50% off on that price up to 2,000 rupees using my coupon code SHSPRO. Republic Day offer. The course would have started just today. Make sure you join it, and yes, the course is in English. Let's start with the first question coming up on your screen. Here it is. All right. What is distance learning course? Madhav, it means you are at a long distance. That means you cannot sit in the classroom. You are learning via correspondence, via either mail or via, online classes. That's like a distance learning course. You're not attending the classes in the premises of that institute. Omai va mau shinderu. Yes. Says Vaishal. All right. Hi Swati, welcome aboard. What's the difference between thermo in chem and thermo in physics? The sign convention, Kalai, and the application. Thermo in physics will not have entropy and enthalpy. We don't study so much in JEE Physics. But in chemistry, you're going to study more about enthalpy and all of that. Also, the applications will be more towards the chemistry side, the reactions. Here we will have springs, forces, all of that, hinges and all of that. So that's the application point of view. But otherwise, theory is the same. It's like one stone and two birds killed at the same time. Okay, some of you are saying A, Natasha saying A, Suchimama saying B, Saja saying A, interesting. Nandini saying A. Are one shots helpful for preparation? Srinivasa, yes, it is helpful when done at the right time. So one shot should not cut out theory. So that's the important thing. When you're studying it for the first time, if one shots cut out the theory, then it is bad. So the way I conduct one shots, whenever I have done, I have extended the class. So marathon. So marathon one shots are good, but one shots for revision is very good. All right. I hope that makes sense. Okay. Many of you have got it correct, and some of you have got it wrong. Well, the answer is zeroth law. Now you might be wondering, sir, 0 comes before 1 and 2, so 0 should be first, right? No, in fact, the second law came the first. That's very interesting. The second law was the first, then the first law came second, and then the 0th law came last. Oh my god, it's so confusing. But you'll be like, sir, then why don't you just name second law of first and first law second and 0th law third? The thing is, what happened was people understood that the first law, let's go behind. The first law is more fundamental than the second law. That's why they kept the first law. And then the second law depends on the first law, or unless and until you do not know the first law, you cannot proceed with the second law. That's the reason why they kept that order. And then after many years, then they realized, oh, wait a minute, there is even more fundamental law than the first law. So that's why they thought, instead of making the first law the second law, and the second law the third law, they thought, let's go behind the first number, which is 0. So that's why they made a 0th law and not the third law. Isn't it interesting? Yep, I hope this is clear. Thank you so much, Sohiti, Sivani. All right. Tamil Tarila. Okay. Okay. So, yes, Subhash, I would love to do that. Is there any -1 law? As of now, nothing. But if something more fundamental comes up, then yes, definitely you will have the -1 law as well. Okay, what is heat? I have explained this again and again. Yes, Darshan, it is confusing. But the point is, 0th law came the last. And because it is very fundamental, so instead of renumbering it again, they thought, let's keep the numbers 1 and 2 as it is. Before 1, you have 0. So this just made a 0th law. As simple as that. Crash course timings will be in the evening, Surya Pandi, Santakumar. Okay? Yep. So, yes, the zero conditional in English. Okay. Alright. So what we have is heat is always the flow of energy, and it's the energy in transit. It always goes from hot to cold body. I have always mentioned this, that the heat always goes from the hot body to the cold body. So the flow of heat always is from the hot body to the cold body, and it flows only till the temperatures are different. Once the temperatures are equal, then the net heat rate is 0, and basically the symbol is Q. We have been seeing that. The formula is mc delta T. I have already told you about this. This is the formula which you will use generally for solids and liquids. This is the formula that you will use. But for gases, the formula that you will be using is Q is equal to Nc delta T. This N is moles. Please understand that. This is moles, and this M over here is basically your mass. So for solids and liquids, you will generally use mc delta T, where that is specific heat capacity. But for gases, you will be using Nc delta T, where C is the molar specific heat capacity. What's the sign like? If Q is positive, like you test positive for COVID, so if Q is positive, then the heat is transferred into the system. Very important. Absorbed into the system. The heat is being absorbed. So the moment absorbed word is used, then I understand Q is positive. The moment the word used is released, then the heat is negative. If Q is negative, then you can see then the net heat is transferred out of the system. That means it is released. Okay, it is released. Very, very straightforward. That's the sign convention of it. Yeah, we have already seen the different kinds of heat transfer modes, conduction and radiation, until it attains thermal equilibrium, because once thermal equilibrium is achieved, temperatures are same, both have the same energy, so there is no way in which the energy will get transferred net. If this guy also have same energy, even if they collide, they won't be able to transfer energy, so there will be no net transfer at thermal equilibrium. Alright, work in your normal 11th standard or even your general mechanics used to be force into displacement. Yes, the same definition is valid, but understand here the work is interpreted in the more application way, as in work done by the gas, work done by solid, work done by liquid is due to expansion and contraction. So solids, liquids, gas can expand and contract, so that's when they do work. And we always define the work done by the system. The work done by the system in chemistry. So please understand, it is different. So work performed by the system. This word is very important. This is only in physics. In chemistry lecture, it would be work done on the system. Correct or wrong? Let me know in the chat box. Sivani, I don't know Telugu, but I can understand few words here and there just because I watch Telugu movies and I know all the famous heroes and all, like Mahesh Babu, Allu Arjun, NTR and all of that. So anyways, so coming back over here, so work done by the system is what you coin in physics, but in chemistry it's work done on the system. Now work is positive. This is very important, the sign convention. It's exactly opposite in chemistry. Work done is positive when the work is done by the system, and the work done is negative when it is done, work is done on the system, not by, this should be on. Okay, this should be on the system. Very, very important. That means if the gas expands, the gas does work. If the gas expands, it does work. So that's why in expansion the work is done by the gas, because it is using its energy, it's pushing the surfaces, and that's how it's expanding. But when you do work, you are compressing, then work is done on the gas. So that's when the work done is negative during compression. So this is something which you need to keep in mind. This is where most of the people make mistakes, and I'll tell you what is the problem. The problem is not remembering it now, but in the exam, because you are going to write 3 papers together, physics, chemistry, maths. So there is a chance you might have the same kind of question in physics paper and chemistry paper, but the signs will be exactly opposite. The formulas will be exactly opposite in sign. So you need to be very, very careful, because you have to switch from chemistry to physics, physics to chemistry. Now I tried calling Wasim sir. He agreed, sir, let's make the same sign convention. Even I said, okay. Then we were like, okay, which sign convention to follow? So Wasim sir was like, since in chemistry we have been using work done on the system as positive, so let's use that. But I was like, no, let's keep it work done by the system. Come on, like work done by the system should be positive. So then we fought, and then we could not reach a conclusion. So then we were like, okay, let's just do whatever you are doing, I'll do whatever I'm doing. So finally we like, okay, let's follow the same sign convention, whatever we have been doing for a long time. Okay, so we could not reach a conclusion. Sorry guys. All right. Okay. So a big chart for all of you, and very important formula. Work done is P delta V in physics. In chemistry it is minus P delta V. Be careful. And when the pressure is not constant, then you cannot use P delta V. You have to use the integration formula. That means it should look something like this. So work for variable pressure will be integral P dV from V1 to V2. This is when you have variable pressure. And whenever you have integration, it also means area under P versus V graph. So that area will give you the work done. Hello twin, hello practical, hello John. Welcome aboard all the lovely warriors. Welcome to Enthuse English, the dedicated channel for your JEE preparation KVPY BitSat, and I hope you have smashed the like button as well as the subscribe button so that you get all the sessions which are going to come up on this channel. Plus you can watch all the videos which were put up on this channel as well. So you can see the area which is under the graph is going to give you the work done. Now be careful. Which work is positive, which work is negative? I have seen many students commit this mistake and then they say this. Sir, if the graph is above, then it is positive, and if that graph is below, then it is negative. Wrong. It's not possible that the graph comes below, because if it is pressure versus volume, how can pressure be negative? So the graph can never be below. In fact, the volume also can never be negative. The graph always has to be in the first quadrant. Be careful. So then you'll be like, sir, then how do I decide the convention? It's very simple. I'll give it to you. See, if it expands, that means the volume increases. That means the graph goes from here to here. If it goes like this, then it is positive because volume is increasing. But if you go reverse from this point to this point along this line, then you will see it will be negative. Understood, my warriors? Yep, I hope this is clear. Welcome all those students who are attending this for the first time. Welcome Vignesh. Hello Saya Kalam. Welcome aboard. Hi Swathakash. Welcome aboard. Yep. So there we go. This is something which you should know. All right. Now this is also a chart which I am giving over here so that you know what is positive, you know what is negative. This is very, very important. All right. So you should know this. Work done by the system positive, work done on the system negative, heat absorbed by the system positive, heat released by the system negative. Very, very easy to understand this. Okay, keep this in mind. Internal energy. Yes, we have spoken about it many times, but quick revision. Internal energy is the sum of potential. Potential comes because of the forces between them, and kinetic energy. The sum of that is internal energy. Which kind of energy does an ideal gas not have? Recollect, ideal gas do not have forces of interaction, because of which they will not have potential energy. So their internal energy is just their kinetic energy. So very, very important. The internal energy, although it is defined as the sum of potential and kinetic, but it is only the kinetic energy in case of an ideal gas. So this formula is only for ideal gases, because you know the potential energy is absent in that. Very, very important. So delta U is basically the change in the potential energy. So the change in the internal energy. The change in the internal energy is basically N CV delta T. What is this CV? CV is your specific heat capacity at constant volume. I hope you remember what were the values for that. For example, for monoatomic it was 3R/2. For diatomic it was 5R/2. I hope you remember this, correct? Yep, very, very important. This is only true for ideal gas. For real gases or for other realistic situations, we do not have, or we do not study the formula, at least in JEE. Now, closed, open and isolated. Many students do not know the difference between them. I'll give you a simple example. Your mom has packed some food for you. Okay, your mom has packed some food for you, and let's say this is how it looks like. I don't know, maybe something like this. And you have this tiffin box, and you have, I don't know, what is your favorite? Maybe sandwich or maybe fries. Okay, you have French fries in this. You have nice French fries in this for your tiffin box. I don't know how many of you carry French fries or potato chips in your tiffin box. You did not close the lid. It is open. That is an open system. Okay, you are not closing the lid. That's an open system. Okay, air can come in, bacteria can come in, bird can come in, donkey can come in, donkey can go out, dragons can fly out of this. Yeah, that's an open system. Closed system, you close it with a lid. Obviously whatever is there inside cannot go out, mass cannot go out, but it's made of, let's say, steel. So heat loss can happen. Heat can go in or out. So you can heat it, you can keep it on a frying pan and it will become hot. That's how it is. And isolated system, you carry it in a nice insulated container. It's insulated, made of hard plastic, and it's a flask kind of thing. There is plastic, there is a thermocol layer, and then there is a steel container like a calorimeter. So there is no heat which can go out, no heat which can come in, and it is also closed on the top. So when you remove the lid, you get hot food as if it was cooked fresh, because there is no heat which has gone out or come in. Understood? So that's the difference between isolated, closed and open system. Very, very important. So in open, heat can also go in, mass can also go in. In closed, mass cannot go out, but heat can come in and out. Isolated system, neither heat nor the mass can go in or out. Very good. All right, very good, very good. Let's get moving to the next one. Looks like some of you have already posted what kind of dishes you guys carry in your tiffin boxes. Interesting to see. Now that's making me hungry. Is ideal gas normal gas? Well, no. Normal gases are not ideal. Normally gases are real, but the gases can behave ideal under specific conditions only. Okay, very good, Aniruddhan R. Nice to know that. Next thing that you should know about thermodynamics: state and path. State and path functions. State means situation. Path means your way, how you travel. Now, why do we have state function and path functions? See, there are certain quantities which only depend on how you are now and how you are then. Doesn't matter how you reach there. Doesn't matter how you reach there. Okay, so those things are called as state functions. You are now like this, you are then like that. How you reach there doesn't matter. What matters is the difference. Just what matters is the initial and the final state. That is called as a state function. Path function depends on how you reach there. How you reach there. That's what it is. Okay, for example, your teacher in school might get angry or might be happy with you depending on whether you do the homework or maybe you get up early and then you reach the school on time. She doesn't care about how you reach, whether you came in school bus, were you stuck in traffic jam, were you did you fight with someone, or did you throw tantrums, did you eat your breakfast? No, she just cares about whether you did your homework last night and whether you came in the class on time. But so that's a state function. Path function will be basically something like how much money you spend on travel every month just for school. So that depends on the path which the bus or your auto or your journey takes. So that depends on the path. It does not depend on what is there before and after only. It depends on how you travel to school. I hope that is making sense to all of you. Yeah. So what are the state functions and what are the path functions? Internal energy. Internal energy is dependent on the state. So it is a state function. Path function, work and heat. How you do the process. How you do the process depends, decides your heat and work. Okay, so that's very important. I'll just put the examples right over here. State functions, enthalpy, entropy, temperature, change in volume, even another example is delta U. Okay, all these are examples of state functions, and path functions are basically examples are heat and even work. All these are examples of path functions. Very, very important, state functions and path functions. Let's start solving a question maybe coming up on your screen right away. Let's see if you can do this. 5 moles of hydrogen initially at STP are compressed adiabatically so that the temperature increases by 400. The increase in the internal energy in kilojoules is how much? Let's see how many of you can do this. Okay, so entropy is the measure of randomness, Suchi. Okay, enthalpy is used more specifically for the reactions that you study in chemistry. Okay, don't confuse between the two. Entropy is a measure of the randomness of that system. All right, let's see how many of you can do this. Come on, my warriors, let's see. figure this out. Hi Sameer Sharma, welcome aboard. $0 before because of COVID, says Rekha Saab. Very good. Selva Kumar says very next to the school, so nothing. Very nice. Hi Hemant Reddy, welcome aboard. Okay, I took Doraemon anywhere and went to school. Okay. Sohiti Sivani, that's interesting. So he is a fan of Doraemon. Okay, interesting. Beyond my generation. I used to like some different cartoons though. Okay, ionization. Okay, let's see how many of you can do this. 5 moles of hydrogen, and you have to find the change in the internal energy. Let's start doing this. Change in the internal energy, that means I need to stick with this formula, delta U, correct, is equal to NCV delta T. That's the formula. Do I know the number of moles? Yes. So N is nothing but 5. Do I know CV? Oh, it's a hydrogen. For hydrogen, what is the CV? Hydrogen is a diatomic molecule. H2 gas. Dia means 5R by 2. So that's why this will be 5 times R divided by 2. And temperature change is 400 Kelvin or 400 Celsius. One and the same thing. Change wise, it's the same because 1 Celsius change is 1 Kelvin change. All right. So I just need to do this. 5 5s are 25 and 4 by 2 is 2 into 100. And there we go. R's value is given over here. It is 8.3. So 25 2s are 50. So I can write it as 5 into 10 to the power 3 into 8.3. Sorry, 25. Correct. 25 into 2 is 50. So 1 0 has come over here. Correct. Now 8 5s are 40. So 8.3 will be, when it is multiplied with 5, it will be slightly more than 40. So which is the number which is slightly more than 40? I think it is B option. Hence option B is correct. Yep. Gamma is Cp by Cv. Yes, that's the ratio. Correct, Kalai Selyan. Yep, it is. All right. So let's move ahead to the next question coming up on your screen. The PV diagram of an ideal gas is shown in this diagram. You can see this is V0, this is 2V0, that is 3V0, P0, 2P0, A is here, B is here, C is here, D is here. Look at the arrow marks, A to B, B to C and C to D. Can you see that? The question is, how much is the total work done by the gas? It's always by the gas in physics. From A to B to C to D, the total work done. Let's see. Okay, come on. Yes. You can write it as 8.3 also. We don't have to find the exact value. You just have to save time, study purpose in the examination. Okay, let's move ahead and see if you can solve this question coming up on your screen. So first of all, think I had given you to calculate the work done in any process. So A to B to C to D is nothing but area under the graph. Area under the graph. Now let's start seeing what is that area. So from A to B, you can see this is the area. From A to B, this is the area. How much area is that? Height is P0. Can you see that? This height is P0. Width is V0. So that area will be P0 into V0 but negative sign. Why negative sign? Is because of the arrow mark. Big volume to small volume. Compression. So this is compression. So this is compression. So negative work. Hence minus sign. Understood, my warriors? Very good. B to C. It's a straight graph. Area under a straight vertical graph is 0. So I'll just put 0 over here. Understood? From B to C, there is no area. C to D, you can find out the area. Again, think about it. So if you find this complete area, okay, this entire area. So let's see how many of you can figure this out. Height is 2P0. Base is 3 minus 1, 2. 2 into 2, 4. 2V0 from here to here, 2P0. So it will be basically 2P0 into 2V0 and it is positive because it is expansion. Can you see the arrow mark? It is that side. So that's why plus. So 4 minus 1, it is nothing but 3P0 V0. Is such option there somewhere? Yes, it is there right over here. I hope you can see that. Very good, my warriors. Perfecto. Excelente. Understood? What a brilliant question. Based on the sign convention, based on area under the graph, and based on your geometrical skills and visualization skills. Simple skills actually, not that crazy also. Okay, so money, you should expect KVPY maybe in March end or March. That is, if the boards do not happen, in the March end, maybe it happens in April, else expect it in May. All right. So moving ahead to the next one. First law of thermodynamics. Now, study purpose, it's very simple, bacha. You just have to calculate this area, the small area, and this big area, because from A to B, it's this much area. From C to D, it's the big area. You can see the height, 2P0, 2V0. The green's height is P0 and V0. Green is compression, yellow is expansion, so expansion is positive, green negative because compression. Okay, moving ahead. See, first law also looks different in physics. Yep, Ramya, correct. Zeroth law I told in thermal physics, Anirudhan, are that, in thermal equilibrium, the bodies stop exchanging temperature. And what happens is, if A is in thermal equilibrium with B and B is in thermal equilibrium with C, then you can automatically conclude without testing A and C that A and C are also in equilibrium with each other. It's like A equals B, B equals C, naturally C equals A. That's the zeroth law principle. Anyways, that was also told in thermal physics, but anyways, I'm repeating over here in case you have not attended those classes. Now I'll give you a simple example and a story, and you'll understand everything, whatever we have to learn. Imagine we have a Pandu. Okay, so this is our Pandu and he's very sad. Can you see his sadness? Can you see his expression? He's very, very weak. He's very, very feeble. He's very, very hungry. He's very, very, he's like, I just need something to eat. So what you do is you give him, okay, what you do is you give him some kind of food. So let's say you give him a burger, you give him a pizza, I don't know, it could be anything. Maybe you give him pizzas, okay, beautiful, Domino's pizzas with lots of cheese and lots of olives and mushrooms maybe. And yes, you can also have some, you can also have some more topics like paneer and I don't know. Okay, let's not get there. Anyways, so this has some calories. This has some calories. Now, what happens is, okay, this is before. After eating that pizza, okay, he gets a lot of energy. Suddenly, Pandu has become fat and happy. You can see the happiness in him. You can see his legs and everything. And plus, he is also lifting something. Maybe he's lifting weights or lifting some box or I don't know. So definitely when he's lifting this up, he's going to do some work, and his energy which is stored inside the body, that means the internal energy has also increased. Do you guys agree with that? Perfecto. Now, yes, this is like conservation of mechanical energy or conservation of energy. What has happened? The calories got burnt and was used to increase his energy, and he could also use it to do some work. So can I not say that calories is basically nothing but heat? So can I not say that Q was equal to delta U plus work? That's it. That is the final equation or expression for first law. As simple as that. Yep. Too much calories and Pandu pops. Yep. You take a pin, pop him, that's it. All the pizza is on your face. You do not want that. Understood, my warriors? Perfecto. So you can never forget first law in physics. In chemistry, it is slightly different because the W term goes over there. So that's where crazy things happen. So, the trick is how not to get confused is basically you remember only for one subject, you automatically remember it for the other subject. Don't try to remember. For physics, it is Q is equal to delta U plus W. For chemistry, it is W plus Q is equal to delta U. You will for sure, guaranteed, get confused in the exam. Don't do that. Remember only for one. Signs only for the work is going to change. So, there are some crazy applications out here, for first law. In fact, I'll tell you, the whole automobiles, the engines, aeroplanes, machinery, the thermal power plants, the power, the energy which comes into your house, the generators, all of this is just based on the laws of thermodynamics. Yes, whatever gases it sucks in, there is combustion which happens, and there is a lot of thermodynamic calculations involved in designing those engines so that it delivers the optimal power to all of you. So you will see that in case you go into mechanical or automobile engineering, but I'm not sure if IC engines would be there by the time you even graduate, and I'm not sure what kind of vehicles you like, because you are the next generation. Do you guys like electric vehicles, or do you like the combustion engines? Are you fascinated by the noise, or do you like that quietness and that instant torque which the electric vehicles give? I'm not sure about you, but you can post it up in the chat box out there. So let's solve this question coming up on your screen. 540 calories of heat converts 1 cc of water at 100 degrees Celsius to 1671 cc of steam. Interesting. At 100 degrees Celsius under atmospheric conditions. The increase in the internal energy will be how much? That's the question. Come on, think about it. How are we going to do this? Okay, Kala is saying electricals. Sohiti is saying Royal Enfield. Selva is going to find some free source of energy. Looks like you're inspired by some superhero movie. I think eco-friendly vehicles are the best. Okay, what is the meaning of eco-friendly? Interesting. What did I study? I studied mechanical engineering and I went into electronics company, and now here I'm teaching physics. So I've done a lot of things in my life. All right, interesting. Electric because it does not harm the environment. Yes, Ramya. Okay, R15. Okay, I like it, Tabu. R15, I like it. From the Star Wars, I like it. You just ask. Oh no, sorry, it was R2. R2. Yeah, it was R2 in Star Wars. My bad. Where you are right now? I am in the studio, in front of the board. In front of you, also in front of the board. I don't know how to say this. Yeah, that's where I am. Akib Bhatt. Okay, my package in engineering. What kind of package? Swiggy? No, we didn't have Swiggy and all of that. Those kind of packages were not there. But packaging was very, unknown to us. We used to go and pick it up. It was like, yeah, we had to go personally and pick up. There was no Swiggy, there was no Domino's, there was no, during our times. So anyways, coming back to this question, how are we going to solve this? Let's go ahead. So first of all, there we go. 1 cc of water. Okay, so we had 1 cc water. It got converted into a big chunk of steam. How much? 1671 amount of steam. Interesting. And 100 degrees Celsius. The question is, what is the change in the internal energy? What is given? 540 calories. So basically, you already know 540 calories is the amount of heat which is given to it. Now think, Q is known, delta U is asked. That means W is needed, work is needed, because I know Q is equal to delta U plus W. So delta U will be Q minus W, and W will be how much, my warriors? P delta V. Now let's start substituting and see what do we get. Q is 540. Let's all do it in calories. Pressure, atmospheric pressure, that means 1 atm. So approximately 10 to the power 5 pascals, right? Pascals. All right. Delta V will be change in the volume. 1671 minus 1, change in the volume. It is basically 1670 cc. Please understand, this is in calories. This is in some weird units. I need to bring it into the same unit. Yep, cc is cubic meter, Swastik. Correct. Alright, you have heard cc for vehicles but never understood. cc is basically cubic centimeter. 11th will be completed in the next few weeks, probably, not more than that. Only one chapter is remaining after this, that's waves, sound and transfers. It will hardly take 2, maximum 3 weeks. Okay, so let's solve this. 540, but this is in calories. Convert Cc into meters, so 10 to the power 5 pascals into converted into SI, so 1670 into 10 to the power minus 6 meter cube. 10 to the power minus 6 because 1 centimeter is 10 to the power minus 2 meter. 1 centimeter cube will be 10 to the power minus 6 meter cube. But this is in joules, SI unit, converted into calories by dividing it by 4.2. Then this entire thing runs into calories. Do the math and you will get the answer 540. So obviously answer is less than 540. So 580 is out of the question. 0, most likely it won't be 0, guys. Check this out. 10 to the power 5, 10 to the power minus 6, 10 to the power minus 1. All right. And here we have basically 167, and that 10 to the power minus 1 comes below, it will become 10, so 42. Guys, 40 into 4 is 160. Okay, I hope you can see that. Oh, 1670, my bad. 1670. 40 into 4 is 160. So I think it is roughly 40. This entire thing is roughly 40. Agree? So 540 minus 40 will be how much? 500, right? So is 500 there in the options? Yes, it is. Yes, it is. Perfecto. Why is it in Pascal as it is in CGS unit? No, it is not in CGS unit. Do you see we converted, this was Pascal, this was CGS. I converted CGS into SI. Do you see that? This was converted into SI units. Now SI units, when I divide it by 4.2, I will get it in calories. I hope that is clear, Dakshin. Yes, thermal property is completed, Siva Kumar. It's done, it's done, it's done. All right. Wow. Moving ahead, I hope this is clear. Interestingo, interestingo. Yes, it was 10 to the power minus 1, but 10 to the power minus 1, when it goes down, what will happen? It will become 10, right? So the decimal will go away. So that 4.2 will become 42 because of that 10 to the power minus 1 on the top becoming 10 below. So that's why 42. So that's why 1670 by 42, roughly 40, roughly. Yes, I hope this is clear. Moving ahead. Understood? And I didn't want to keep that calorie in that way because first I want to convert it into joules. So Pascal, I kept it as it is till I got everything in joules, and eventually I divided it by 4.2 so that I converted it into calories. Perfect. What a brilliant way of solving this question and a good application of first law of thermodynamics. Yes, I do know, Soiti, I do know about BTS, but I'm not so addicted to BTS as of now. Alright, I'm that old school kind of guy who likes the 70s and the 80s and the 90s music. I'm fond of rock and roll, punk rock, metal, and you name it, and the 90s music, of course. Yeah, I do like those kind of songs. Alright, now what's the cyclic process? See, and what is the importance of cyclic process, though we are going to have a detailed class next time on cyclic process. See, when you start an engine or anything, it sucks in the gas, it does some combustion, and there is exhaust. And again, it pulls in the gas, and again it combusts, and then it delivers power, and again it throws out the gas. It repeats, so it's a repeating thing. Cyclic means repeating. So there are so many times where the same gas undergoes the same thing again and again and again. Okay. So basically, when it repeats, you will see when it comes back to the same point, when you come back to the same point, what will you see? The state function change will be 0. That means internal energy will not change when you come back to the same point, whether you go like this or whether you come like that. So the change in the internal energy will be 0. That means you can also say by first law, heat is work. Observe this, Q is W. Actually think about it, Q was W plus delta U, but delta U will be 0. Therefore Q is just W. Very, very important. Change in the internal energy is 0. The reason is it's a state function. It's a state function in a cyclic process. So start from this point, come back to the same point. No change in the internal energy. I hope this is clear. All right, all right. Good evening, Anil. Welcome aboard. So, like I was saying, the combustion which happens in the engine is a very good example of a cyclic process. You can see the state changes and there are so many things happening, but it repeats itself. It keeps on continuing again and again because it has to constantly deliver power. Now, based on what kind of things happen, yes, it's the same in chemistry also. Aryan physics is good for JEE NEET, not completely enough, but you need more books, Krishna. Okay, so understand there are different kinds of processes based on what is happening over there, whether pressure is constant, volume is constant, heat is not going in or out, or something else, of course. So we're going to study all of them in detail now, but before that, some questions in front of you. Here it is. First question coming up on your screen based on the graphs and cyclic processes and the state functions and the first law. Following diagram will show you two processes, A and B. This is initial, this is final. You have to figure out if delta U and delta U for both the processes are given in this form, and Q for both the processes are also mentioned over here, QA and QB. This should be QB, guys. Then which one is more, which one is equal? I don't know. Let's see how many of you can get this. Quasi-static, you would have studied that in chemistry, of course, Dakshin. Quasi-static is nothing but the process which happens very slowly in equilibrium. You do not expand it suddenly, you push it, you let it settle down, and you push it and let it settle down. So you always know each and every parameter of that gas at every point of time. That is the quasi-static process. A sudden process is not quasi-static, okay, because then it might not be reversible. All right, let's see if you can get this. Oh my god, so somebody is suggesting me I should listen to BTS. Fine, I'll become RV. Okay, probably in my free time. And think carefully. This is initial, this is final state. How is it going to work? This is initial, that is final state. How is it going to work? See, remember, delta U is a state function. I had mentioned this. Delta U is basically a state function. Path independent, right? Path independent. That means, think about it, delta U for process A and delta U for process B should be same. Okay, the paths could be different, but the initial and final states for both the processes are the same. I hope this is clear. So delta U is same. What about heat? For that I need to be a little bit careful. Remember, Q is delta U plus work. Q is delta U plus work, and the work will not be the same because work is area under the P versus V graph. Do you remember that? Now observe carefully. If you take these 2 points and now if you calculate the area under the graph A, look at this. This is the area under the graph A. And if you see carefully, you will also see the area under the graph B. This is the area under the graph B only. These two are obviously different. Which area is more? Which area is more, A or B? Obviously A. So hence, one can easily commit and say work done by A is more than work done by B because of area. That means Q of A is more than Q of B because delta U is same. If this is same, this is different. Whichever has more work will also have more Q. Understood? Very straightforward. Hence, is there something? Oops, looks like C and D both. Looks like there was a misprint, guys. Okay, this was not supposed to happen. I'll edit it in the final PDF. Okay, I think there was some change. Maybe this was supposed to be less than, or yeah, either C and D, both options are same. Yes, Natasha, correct. Swastik. Okay, so it's a misprint. Don't worry about it. Okay, ma'am, I'm taking Vani Mama class. Arey Baba, Yash, you are completely changing genders. I am Mama, Vani ma'am. Please, don't do this. Don't do this. So I can't take your class now. Okay, but at least see whom you are talking to. Don't do this, bacha. See, I don't know whether you have turned off the screen or what, or you cannot listen, or you're just typing. Yeah, be careful out there. So here is the next question. Here is the next question coming up on your screen. Okay, here it is. This is a brilliant question. You're going to enjoy this. A thermodynamic system is taken from initial state, internal energy 100 joules, to the final state right over there. Read it. Two different paths, IAF and IBF. I, point B is here, F, as shown. Work done along the paths AB, IB and BF. Everything is given. And also the heat supplied along the paths IAF, IB, BF is marked right over here. UB, internal energy at B, is also given. QIAF, heat in IAF, is also given. The ratio of QBF by QIB. Let's see how many of you can get this. Very, very interesting question. All right. Now, what has been asked? QBF by QIB. B to F, I to B. Let's start solving this one by one. Okay, observe. QIB, that means this process. Okay, from here to here. I need to find that because I want to find the ratio. Let's see if I can do it somehow. WIB is known, UI is known, UB is known. Think delta UIB will be this number minus this number. I know the final and I know the initial. This is initial, this is final. I hope this is clear. That means this will be 200 minus 100, which is just 100 units or 100 joules, whatever. Okay. Now, using first law, look at this, using first law, can I not say QIB is equal to delta UIB plus WIB? Now, QIB, I don't know, that's what I need to find for this guy. Delta UIB, I just figured it out as 100. WIB is mentioned right over here, 50. So plus 50. So this will be 150 joules. So that is QIB. So that is one thing. I'll just block it and keep it. QBF is going to be one challenging aspect. Reason, I do not know delta U between these 2 points. I do not know the work between these 2 points and all of that. So I need to do something else. Probably I can do one thing. If I know delta U and other things like over here, I just mark it. See, from B to F, I told you it's a very challenging problem. From B to F, if I have to go, so I should write QBF will be equal to delta U BF plus WBF. WBF. Oh, I know WBF. Delta UBF, I don't know. I don't know that. I just know WBF. WBF is nothing but from there, it is 100 joules. Can you see that? This is 100 joules. So in order to find QBF, I just need one more thing, and that is delta UBF. Everybody clear till this point? Acha. Now, what do we do? In order to find this delta U, maybe I should find this delta U, because I know this delta U, the yellow one. To find the red delta U, since it's a state function, I should find the total delta U between I and F. And I know delta U does not depend on the path. So instead of finding the delta U for IBF, I can find the delta U for IAF. I can find the delta U for IAF. Understood, my warriors? Let's try and find that out and see what do you get. How do I get delta U for IAF? That I will get it by probably again using first law between IA and F. So let's use this process and see what do we get. Okay, from here to here, and see what do we get. Observe this carefully. If I use Q, is it known? QIAF. Acha, QIAF is known. Interesting. QIAF is known. Interesting. So QIAF is delta UIAF plus WIAF. Interesting. Now QIAF is mentioned right over here. It is 500. Delta U IF, I need to find that, because only when I find delta U, I can find delta U for this process. Okay, so delta U IAF I want to find, plus work done in IAF will be work done from I to A plus work done from A to F. Work done from I to A plus work done from A to F. Next, 500 will be equal to delta U IAF. Understand, in this process, for this initial and this final state will be same for delta U from IBF. Agreed? It will be the same as delta U from IBF because it's a state function. It's a state function. Plus work done from I to A is 0 because the area under I to A is 0. Agreed? Disagree? Agreed? Disagreed? I to A there is no area, so I'll put 0 over here. Plus A to F, I think it is mentioned somewhere here. Look at this, work done from A to F is 200. Therefore, delta U IBF will be 500 minus 200, which is nothing but 300 joules. Perfecto? Agreedo? Excelente. Now, delta U IBF, the change in internal energy in this process is from I to B plus B to F. What is from I to B? I think I got it. It was 100. I had found it out right over here. I to B was 100, and from B to F, that's what I need. Delta U BF is exactly what I need. I hope that is clear. That is nothing but 300. So from here, I'm going to get delta U BF is going to be nothing but 200, I suppose. Just check this out. Okay, delta UBF will be 200. Yes, that's what it is. So use this over here. So use this right over here. I'm going to get this as 200. So that means it is going to be 300 joules. So that is QBF. That's what I got. Now what is asked? That is the simplest part. The simplest part. This ratio is asked. So what will this ratio be, my warriors? This divided by this. QBF, which is 300, divided by QIB, which is 150, which is nothing but 2. Done, done, are done. Option A. Got it? Wasn't it a brilliant question? Loved it? So many intricacies, so many dependencies. You have to go, by different paths to find out each and every term. That's the fascinating part about this problem. It's a JEE Advanced question. Yep. I hope you have enjoyed this question, and if you have enjoyed the explanation too, go ahead, smash the like button. It will make my day. Thank you so much. Alright, moving ahead. Tattva material plus Irodov and the assignments that we give you is enough for JEE Advanced. Trust me on that, plus HC Verma and all that. Standard books. Now let's go to the processes. Very interesting processes coming up on your screen now. Isothermal. So what is isothermal? Like I have mentioned right over here. Isothermal means temperature is same. Now a lot of people misunderstand isothermal process. Many people think isothermal means you should not heat it. That is exactly wrong. Isothermal does not mean you cannot heat it or you cannot cool it. In fact, you can to maintain the temperature. Remember, isothermal is a process where you maintain the temperature. So try to remember it that way, it will be easier. So you try to maintain the temperature, and the work done for isothermal process will be nRT ln V2 by V1. Very, very important formula. I'll just block one of them. nRT log V2 by V1. You should remember it. You would have studied this back in chemistry. Isothermal process, obviously, what will be constant? Temperature. Temperature will be constant. Rather, I would say or use the word maintained. Somehow you maintain it. And if temperature is constant, P into V will also be a constant. Pressure into volume will be a constant. Now, if temperature is a constant, then it also means delta U will be 0. So there is no change. Understand that. For ideal gas, delta U will be 0. NR delta, NCV delta T. Delta T will be 0. Because of that, delta U will be 0. And Q, which is delta U plus W, will be looking like this. Q will be equal to just W. Very, very interesting. So I can just say all the heat goes into the work. Very, very interesting. All the heat goes into the work. There is no change in the internal energy. Understood? Perfecto. Now, if you know all these things, you will be able to solve the problems easily. Remember, in chemistry, there was a minus sign. There is no minus sign here. And this is final by initial. Very, very important. I'll just mark it just for your reference. This is always final and this is always initial. Okay, keep this in mind. This is in physics. In chemistry, you have it reverse, and or you can also put a minus sign. It's one and the same thing. Let's take some examples. Obviously, fridge. A lot of you think it's an adiabatic process. That's wrong. Whatever things are kept in the fridge is in fact in isothermal condition. You set the temperature. If anything becomes hot, it tries to cool. If anything tries to become overcooled, then it tries to release that coldness, and it tries to maintain it. So it tries to balance the temperature, maintains the temperature. In fact, even boiling water or even melting ice is the example of isothermal process. Not many people know that. In fact, any change of phase. So whenever phase changes, the temperature remains constant. It is an isothermal process. Until the complete ice melts or until the complete water boils and evaporates, it will not change its temperature. Here is your first question on isothermal process. Here it is. Okay, glad you liked it, Tamil. All right, moving ahead. Fridge temperature is constant. It is. Okay, once you set the temperature, it will always try to maintain the same temperature. So yes, it is an isothermal process. Hello Yasin, welcome aboard. Like black body absorbs all the light? No, Sochi, not exactly that. You should not take the example of black body. Okay, so why there is a slight change in the first law? Like I said, there were different conventions, and in chemistry, it's always the surroundings which is given a priority, so it's always work done on the thing. But in physics, it's always work done by the system, or system is given the priority. That's how it is. Okay, so a cylinder fitted with a piston contains 0.2 moles of air at temperature of 27. The piston is pushed so that the air within the cylinder remains in thermal equilibrium. Very interesting. In the surroundings, find the approximate work done by the system if the volume is twice the initial volume. Okay, the piston is pushed slowly so that the air within the cylinder, okay, is equilibrium, thermal equilibrium. That means you should first remember that this process is isothermal. And what is asked in the question? Work done. And the work done formula is nRT log V2 by V1. So let's start substituting whatever we know. N, number of moles, is 0.2. R value, am I supposed to put it in R? I think so. So R value, I'm just going to put it approximately as 8.3. You can substitute the exact value as well, but I think it's fine because options are there. Temperature 27, don't put it as 27, put it as 27 plus 300. Sorry, 27 plus 273, which is nothing but 300 into log of volume is twice. That means V2 is twice. So 2V by V2. So if you want, you can write it as 8.3 into 2 into 30. Okay, into 30, one of the 0 goes, and into ln2. Now do the math and see what you get. So you will get this as 8.2 into 3 2s are 6. There is 1 0. Log of 2 is 0.673. So I can write it as approximately 6.7. That 6.7 has come because of this 0 over here. One of the 10 got multiplied. So come on, do this math. You will get the answer. Okay. 8 6 and into 6 approximately. Swastik saying 343. There is no 343, bacha. Are you seeing any 340? 345 is there? So maybe B. Yep, very close to that. 345. Yes, that's what you're going to get. Yep, very good, very good, very good. Excellent. Understood? So very straightforward. Gautam, I would suggest you go with H.C. Verma, Rodov and PYQ of Arihant along with Tattva material. Guaranteed success in JEE Advanced. Alright, moving ahead to the next one. Adiabatic process. Adiabatic process. So what do we have? Adiabatic process means where your heat cannot come in or go out of the system. It cannot enter in or cannot go out. Example, thermos flask, calorimeter. That's it. It's trapped. It's a isolated system. Yes, Q is equal to 0. And I can also say PV raised to gamma is a constant. PV raised to gamma. Gamma is your that ratio, Cp by Cv ratio. So gamma is nothing but Cp by Cv ratio, which you have studied back in kinetic theory of gases. This is constant. Q is of course 0. Therefore, work plus delta U is 0. So Q is 0, work plus delta U is 0, and work is minus delta U. And delta U, we all know, is nothing but minus N Cv delta T, and Cv, we know it is nothing but R upon gamma minus 1 into delta T. If you want, you can put that minus sign inside and it will look something like this. NR delta T divided by 1 minus gamma. So that is your work done formula. Very, very straightforward derivation. NR delta T upon 1 minus gamma. In case you forget it and you don't remember whether it was gamma minus 1 or 1 minus gamma, I have shown you the derivation. It is hardly 2 to 3 steps, but don't make a silly mistake in the examination. Understood? Perfecto. Is scientific calculator allowed? No, no calculators are allowed. No logbooks are allowed. Okay, very, very important. So, and in physics thermodynamics didn't say that. Okay, so I'm not sure what was not said to you, Sivani. All right, moving ahead to the next one. Okay, so for me in physics thermodynamics didn't start, but I'm listening one short section. No problem, no problem. It's okay. You'll already have a head start. It's always better to learn earlier than to learn later on and have a backlog. You can definitely understand it much better once it is taught in your regular coaching or whatever in your school. Now, another important thing, how the graphs look like. So isothermal and adiabatic, the graphs look very similar, but there is a small change. See, very, very important thing that you should know, if you have a pressure versus volume graph, correct? And if you talk about an isotherm, pressure into volume is constant. This is isotherm, okay? The graph of adiabatic process also looks very similar, but there is a small change, the slope is slightly more. So what happens is, for adiabatic process, you will see the graph is steeper. This is adiabatic. This is adiabatic. It's slightly steeper. In fact, the slope is more than the isothermal slope by gamma times. Very, very important. There were questions in JEE Mains many times on this concept. So I'll write it over here. Slope of adiabatic. Slope of adiabatic P versus V curve is equal to, I'll just put it right over here, gamma multiplied by the slope of the isotherm, in your P versus V graph. Very, very important result, which I am putting right over here. Very, very important. And it is more gamma times. This gamma is important. Gamma is a number always more than 1. Remember that. Okay, it's always more than 1 because Cp is always more than Cv for ideal gases. So keep this in mind. Perfecto. So, I don't know whether you have studied this back in waves. Depends on if you have studied waves or not. Over here, I have not yet taught waves, but you might have heard about Newton coming up with a formula for the speed of sound and then Laplace modifying it and giving the correct formula. So, you know, the problem between so the problem of Newton's formula for the speed of sound was that Newton thought that when there are compressions and expansions of air, then the temperature remains constant. But the fact is, it's in fact, it's an adiabatic process, because when you expand or contract the air suddenly, when you contract and expand the air suddenly, there is hardly any time for the energy, the heat to get exchanged. There is hardly any time for the heat to get exchanged. So that's why sudden processes are basically, adiabatic process. I hope that is clear. Ramya, we have already taken care of few questions of, JEE Advanced for thermal physics. But yes, dedicated sessions for JEE Advanced are coming. Let me complete the theory. For sure, they are coming for all the chapters, not just thermal, everything. Modern physics, everything. Got it? Hello Neeraj, welcome aboard. So sudden processes are adiabatic, keep that in mind. Let's solve a question on adiabatic process. Find the final temperature of 1 mole of an ideal gas at initial temperature of T Kelvin. This is supposed to be off, not 2, of T Kelvin. The gas does 9 R joules of work adiabatically. The ratio of specific heat of this gas at constant pressure and at constant volume is 4/3. So Cp by Cv ratio is given. Let's see how can we do this. Okay, let's see. What do we know? What do we have? Okay. Final temperature has to be found. Initial temperature is given at constant volume, that too. Okay. Initial temperature is given T. The Cp by Cv ratio is given. What we need to do, let's try to do it with the formula. Work done is nR delta T upon 1 minus gamma. I think I know the work, yes. I know the gamma, yes. R, okay. N moles, yes. Delta T, I think I can do that as well. Work is 9R, so just put 9R. N, 1. R, delta T, final minus initial, so TF minus T upon 1 minus gamma. Gamma is 4/3. RR goes, so 9 will be equal to T final minus T, right? And 1 minus 4/3, just check it out. 1 minus 4/3, it's minus 1/3, right? So let's just put this as minus 1/3. Shift it here. 1/3 into 9 will become 3. So it will become minus 3 is equal to TF minus T. So TF will be, take that T over here, it will become T minus 3. So that's our final goal, T minus 3. Yes, it is there. 3 Kelvin change. Adiabatic process same as polytropic process? No and yes. I'll tell you why in a bit. Okay. In fact, adiabatic process is a polytropic process, but every polytropic process is not an adiabatic process. You might get confused, but hold on, I'm coming to polytropic process as well. Can I throw the bottle down? Sohiti Sivani. Okay, Sohiti Sivani, I will drop the bottle down. What will you give me? What will you do? Then I will throw the bottle down. Okay, so there has to be some challenge, right? Only then I can take it up. Anushka, I think I just mentioned don't spam bacha. Okay, moving ahead to the next one. Isobaric process. Chocolate. For one chocolate, I will throw and break my beautiful bottle. No. Dairy Milk Silk Oreo, too sasta. Something more. I just had Dairy Milk Silk, by the way, just yesterday. Yeah. Okay. So, what do we have? See, isobar. Isobar means constant pressure. And when pressure of the gas is constant, let's go here. P is constant. Like for example, you are heating a liquid open to the atmosphere, the pressure is constant on that liquid, so it's an isobaric process. Pressure is constant, then volume is directly proportional to temperature. And the work done will be P delta V. And also remember one more thing over here, I'll put it. Work done is P delta V because P is constant, remember, there is no need of integration. Delta U is always NCV delta T, and Q by definition is NCP delta T. Notice the difference. It's a isobaric. Isobar means C will be CP, specific heat capacity at constant pressure. Got it? I hope this is clear. Subha Narayan, what is the timestamp? You are watching it live, bacha. So boiling water, look at this. Boiling water is isobaric plus even isothermal, by the way. Okay, till it reaches the boiling point. Once it reaches the boiling point, it is isothermal. But when you are boiling it and it is not yet 100 degrees Celsius, that time it is just isobaric. It has not yet reached isothermal stage. Only when it is actually boiling, that's when it is isothermal. Let's solve a question based on this. Alright, Dairy Milk Silk Oreo. Oops, nothing more than that. Sohiti Simani has raised up the hand. Sir, I can't give more, sir. I got this much only, pocket money. Nothing more. It's okay. I'll drop this bottle maybe some other day when I have some cushioning. Not today. Okay? I will get thappad from my wife. Okay? And if my wife sees this, trust me, probably I only have to clean everything and all of that. So let's not take that risk. Okay, okay. I don't want anything, Sohiti. I just don't want to get scoldings from my wife, you know. Shh. Alright. So, when an ideal diatomic gas is heated at constant pressure, the fraction of the heat energy supplied which increases the internal energy of the gas is how much? Let's see. Charles' law. Yes, Dakshin, correcto. Charles' law it is. Yep. Isobar in chemistry signifies same mass number and different atomic. That is in the different perspective, Suchi. That's in the perspective of radioactivity. Yes, that term is also used there. But isobars in laws of thermo or gas laws also means constant pressure. So, like in English, one word can have two different meanings, double meaning, triple meaning. That's what it is. Okay, cool. No problem, Anushka. So, how do we do this? The fraction of the energy supplied which increases the internal energy of the gas. So, think about it. Let's start. Fraction. What do you mean by fraction? Fraction is a ratio of the heat supplied which increases the internal energy. So, what we need to find is how much is delta U upon how much is the heat supplied. That's all we need to find. That's it. Delta U upon U. Q. Now delta U is always NCV delta T. Always. I have told you this. It's always. No matter which process you take. Q. It's at constant pressure. That means it is NCP delta T. Delta T gone. N by CV by CP. Oh, wait a minute. I know this. CP by CV is gamma. CV by CV is 1 by gamma. And what kind of gas it is? It's a diatomic gas. Diatomic gas gamma. I know gamma is 7 by 5, right? It's 7 by 5. So this will be 5 by 7. Do I have such an option? Yes, I have. D. Kesav, is it possible to complete all topics of 11th in 1 month? If that was possible, Kesav, then I could complete the entire JEE syllabus in 2 months. Why do we study for 2 years? It's not possible. But it is possible to get the understanding of 11th standard in 1 month, and you can develop and build your base and then develop your skills, calculation, speed, accuracy, depth in the knowledge, the breadth of the knowledge, everything in the next few more months. In the next 1 month, yes, you can get a good understanding of what is there, halka fulka idea, you can get an overview, you will be able to understand the gist of it, okay, and that is important now, and later on develop your skills. Is that okay, Kesav, Pradeep? Okay, moving ahead to the next one, isochoric process. Okay, all right, I'm so glad, Shivani, you're liking it. Hello, Amrit. Okay, how gamma is equal to Dakshin? It's a diatomic, bacha. It's a diatomic. So for mono, remember? So for mono, CP by CV. CP always had that 5 R by 2, Cv had 3 R by 2, so it was 5 by 3. For dia, remember Cp and Cv. Cp had 7 R by 2, Cv had 5 R by 2. So 7 by 5. That's how it comes. Okay? Fair enough? Alright. Moving ahead, isochoric. Isochoric is one of the easiest and lovely processes because the work done is zero. Because volume is constant. If volume is constant, no expansion, no contraction. Work is done only when there is expansion and contraction. So no work done. Things are very, very simple. So here is what I'm going to say. The work done is zero, as simple as that, because there is no expansion or contraction. And if work done is zero, Q, which is equal to work plus delta U, therefore I'll get Q is equal to delta U, and from this I'll also get Q is equal to delta U is equal to NCV delta T. This is a straightforward relationship. This is only true for isochoric. Q is delta U and it is also NCV delta T. Gas laws wise, we all know volume is going to be a constant, so therefore pressure is going to be directly proportional to the temperature. That's straightforward. You have studied this back in chemistry as well. Fair enough. By the way, all notes are available. Whatever I write on the board, you will get it in the form of PDF. You just have to join the Telegram channel. The link is there in the description box below. In case you have not joined it yet, go join it ASAP so that you get all the notifications with the PDFs and all the lovely handwriting that I have done for all of you. Yep. So there you go. Example of isochoric process, guys. See, boiling the water again. How many times are we boiling the water? I think the water has evaporated. That reminds me, I should drink water again. So boiling the water in a closed container, it can't escape. The gases are trapped. So that's the isochoric process. Yep. Very good. Yes, Raja, you have learned chemistry already, so that's why it looks easy. Hi, Bidusmita, welcome aboard. Hello, 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 hello. Yep, welcome, welcome. So let's start solving some questions. If you guys are geared up and ready to solve this. Oh guys, by the way, I don't know whether I mentioned this. This is going to be a long lecture, so expect the lecture to continue for more 20 minutes. I hope you're not hungry, and in case you're still hungry, call your mom. Mom, I need food. I can't get out. I can't get up from my laptop. I cannot get up from my mobile screen. Please serve me in the bedroom. Okay, please do that. Okay, the vessel will explode for sure. Abhishek Kushava, hello, welcome. So there we go. In the process ABC for an ideal this is interesting. Ideal monoatomic gas, the temperature at A and C are equal. Very interesting. The heat released in the process B to C is Q. Work done from A to B is how much? Wow, this is going to be a very, very interesting question. First of all, let's write down whatever we know. A and C, the temperatures are same. Okay? A and C. If TA is equal to TC, delta T from A to C will be 0. Delta U from A to C will also be 0. No change in internal energy. Fair enough. What do we need to find? The work done from A to B. The work done from A to B, from this point to this point. That's what we need to find. In order to do that, what do we need? First law maybe. Q from A to B will be delta U from A to B plus work done from A to B. Okay, fair enough. I don't know this, I don't know this. If I know both of them, I can find the work done from A to B. Okay, how do I do that? I think I need to make use of this fact. The total change in the internal energy is 0 and heat released in the process BC. There we go. Heat released in the process BC is Q. Very interesting. Let's see what do we do now. Q in the process BC is minus Q. Do you guys get it? Why? Do you guys get it? Why? It's minus Q because it is given release. Release means negative. Also, graphically, B to C, it is nothing but an isochoric process. I don't know whether you realized it. It's an isochoric Isochoric process. So work done from B to C is 0. Wow. So QBC is equal to WBC plus delta UBC. This is first law. Okay, this is your first law of thermodynamics. QBC is minus Q, work done 0 plus delta UBC. So delta UBC is minus Q. I needed this so much because I know delta UAC, the change in internal energy from A to C, is actually nothing but delta UBC plus delta UAB. I don't know whether you got this, but I'll explain again. The change in internal energy from A to C is the change in internal energy from A to B plus change in internal energy from B to C. Now you got it? Now B to C, I know it. How much is B to C? It is nothing but minus Q. So all I need is how much is delta UAB. So from this I got, therefore delta UAB is how much, guys? Shift that minus Q on that other side. It is just going to become Q, I suppose. Q, I suppose. Everybody got it? Everybody got it? Perfecto? Okay. Now, what else is remaining? Think about it. Think about it. What else is remaining? Okay. Now, okay, please give me reply, NAK reactions. I don't know what you want to ask. Okay, how am I teaching chemistry? Abhishek Bacha, this is, I know this looks like chemistry, but this is also there in physics. Don't worry about it. Okay. Now, what do we have? The work done in the process A to B. QAB, do I know it somehow? I don't think I know Q from A to B. Delta UAB, yes. How do I find QAB? Think about it. How do I find the heat from point A to B? QAB remains. Where does it remain? Where does it remain? Think. Where does it remain? Where does it remain? Think about it. Where does it remain? QAB. I have to think about this process. It's an ideal monoatomic gas. The temperatures are same. Guys, A to B, it's an isobaric process. A to B is an isobaric process. Can I do something about it? Maybe. Let's try it out. Q from A to B will be, observe, NCP, okay, delta T. Okay. Since it's a monoatomic gas, what will be Cp? Since it's a monoatomic gas, what will be the value of Cp? Think about it. What will be the value of Cp? I will get it as 5R/2. But, okay, let's just try it out. It will be N into 5R/2 into delta T. Interesting. And delta U is nothing but, think about it, it's NCV delta T, always. So it will be N 3R/2 into delta T. Correct? Now I think I got some idea from here. Observe what I will do. See, if you equate the two, you will get from here NR delta T by 2. NR delta T by 2 is, take that 3 below, you will get it as Q by 3. You will just get it as Q by 3, correct? So delta U is NCV delta T, CV is 3R/2. So from that I got NR delta T by 2 is Q by 3. So I think I have the term NR delta T by 2 over here also. So QAB will become 5 multiplied by NR delta T by 2 is nothing but Q divided by 3. So I think I have got QAB as well. So now let's start substituting and see what do we get. So QAB is 5 Q divided by 3. Delta UAB, delta UAB is just nothing but Q. So plus WAB. So WAB will be 5 by 3 minus Q, which is how much? 2Q by 3. Is 2Q by 3 there somewhere? Yes, it is there. Very interesting. Okay, so till here everything was smooth. The problem was QAB was unknown. So what I did, Q by definition is NCP delta T. CP is 5R by 2. Delta U by definition is NCV delta T by definition. That means CV, if I put, because it's a monoatomic gas, it's clearly mentioned mono, CV will be 3R by 2. From this I thought, acha, I know N R delta T by 2 will be, take that 3 below Q, it will be Q by 3. So I got the value of NR delta T by 2 as Q by 3, and I use this value over here to get it in terms of, I got QAB in terms of Q, because the final answers are only in terms of Q. So I use this over here. Delta UAB, I already knew it is Q. I rearranged, I will get it. I hope this is clear. No problem, Shivani. This session will end in another 5-10 minutes, maybe, not more than that. All right. Since it is isothermal, Swastik, isn't delta T equal to 0 in this? Where? Where is delta? No process is isothermal. A to B is isobaric, B to C is isochoric. So isobar, isochor, so no process is isothermal in this. A to C is isothermal. A to C, if you go, because delta T is 0 from A to C, observe that, not from A to B or B to C. I hope that is clear. Okay, Swastik, fair enough. That's a very good question. Lot of, intricacies, interdependencies were there. No problem, terrible. You can probably replay the class and you can go back even in the live class. Now, what is the meaning of a polytropic process? Remember, polytropic process is a generic way of representing a form of processes in a specific mathematical way, if they are written down in a specific mathematical way. So basically, any process which is PV raised to N is any number, any real number, is a polytropic process. Example. No, it's not a new board, it's just that I have shifted to black. For example, PV is constant. Pressure into volume is constant. Isn't this isothermal? Isn't this isothermal? Now, I don't know whether you saw that, but over here, the power of volume is 1. This is also polytropic process. Pressure into volume is constant. Similarly, I can also say, let's say pressure is constant. Pressure is constant. This is nothing but isobaric process. You might be like, sir, there is no V here. How is this polytropic? Observe this again. Actually, there is V raised to 0 here. So it's also in that form, PV raised to something is constant. You can write even for adiabatic same way. PV raised to gamma is basically constant, is nothing but adiabatic. Is nothing but adiabatic. So again over here, that gamma is that number which we are talking about. In general, any number, this n can be belonging to any real number. That kind of process is called as polytropic. Okay, it could be even neither of these. It might be some weird process, some random thing like this. Spring is attached, gas is there, it is being heated. It's not isobaric, it's not isothermal, it's not adiabatic. It's some random thing, but it is following that law. PV raised to something is constant. That's polytropic. And some things which you need to remember. Observe this carefully. Hardly few things are remaining now. Saying even for a polytropic process, delta U is always NCV delta T. This never changes. Okay, keep this in mind. Similarly, work done. Remember, for adiabatic process, it used to be N R delta T upon 1 minus gamma. But instead of gamma, you put this N or whatever. So this will become the work done. And Q, you can find it out by first law, which is W plus delta U. That's your first law. As simple as that. Okay. So is that understood? So polytropic process is all process which can be expressed as PV raised to N Isothermal, adiabatic, isochoric, all these are also special cases of polytropic process. Mr. Tawfiq, rotation done long time back. We have rotated it long time back. Okay, we have almost come towards the end of 11th now. Is there a place where I can find all the classes of physics in orderly manner? Definitely, Keshav Pradeep. I made a beautiful, playlist for you. It is called as a nurture playlist. Stay with me till the end. I will show how to navigate which playlist you should watch. Hold on. Okay. What is the difference between thermal physics and thermodynamics? So in thermal physics, we study about temperature, heat, and also calorimeter and KTG, let's say. So basically, we are talking about what is the basic of temperature, what happens when you heat something, how does it expand, cool, contract, and then we are also talking about the different terms used in heat transfer like heat capacity, latent heat, etc. In thermodynamics, we concentrate more on the processes like isobaric, isochoric, cyclic, and the laws of thermodynamics. That's what we concentrate on. Okay, Pamisha, it's just the name of the chapter, but I have told you the contents of it. I hope that clears the air. All right, so moving ahead, the molar heat capacity in the process of diatomic gas is if it does work of Q by 4 when Q is the heat supplied. Okay, this is interesting. Let's see if we can do this. The diatomic gas, the work of Q by 4. So work is Q by 4. Okay, heat is Q. So Q is work plus delta U. So let's just find delta U and keep, maybe I need it. So Q is Q, work is Q by 4, and delta U I don't know. So from this, delta U will be 3Q by 4. Interesting. Now delta U, we know it that the molar heat capacity in a process. Okay. Now think delta U, we know by definition is NCV delta T. NCV delta T, correct? By definition. For no matter which process you go, delta U is always the same. Q may not be the same. Q is not always NCV delta T. Q will depend on the process. For isochoric, it is NCV delta T. For isobaric, it is NCP delta T. Q will change from process to process. What process is it? I don't know. I don't know what process it is. So I'm just going to put Q as NC. I don't know what C it is. Just delta T. Is that making sense to all of you? Okay, I just don't know what kind of C I should put. I'll just put it C for that process. Yep. KTG is also there, Bhavisha, in nurture series. Yep. So moving on, NN goes, delta T goes. So I'll be left with CV is equal to 3 by 4 times of C. CV for what kind of, oh, it's a diatomic gas. Diatomic means 5. So 5R by 2 is equal to 3 by 4 into C. This 2 and this 4 goes. So C will be 2 5s are 10, R divided by 3. I think it should be there somewhere. Yes, it is there. Option C is correct. Yes, Gunjan, correcto. So what have we done? Using first law, we found delta U. Next, definition wise, delta U, I have told you every time, NCV delta T. Q, depending on the process, it will be NC for that process. That C is for that process. Remember that. I don't know what process it is. Okay, I don't know. That's it. And the rest is simple. Okay, next question coming up on your screen. Yes, NAK creations have covered all the topics, but I would advise you not to watch Zero to Hero unless and until you are clear about the basics of it. It's a good one-shot series, but you can watch it in the start or even at the end. You'll get a good idea. But if you want to get more detailed classes, more problems, then after Zero to Hero or before Zero to Hero, watch the other classes because you have a lot of time, bacha. Okay, NAK creations. For polytropic process, P by V is constant. The molar heat capacity of the diatomic gas is, let's start doing it. P by V is constant. Guess what? This is actually a polytropic process. You might think, sir, this is isothermal. No. It is not P into V. It is P by V. P by V is nothing. So in fact, it is P. Oops. It is actually speaking P into V raised to -1 is a constant. So this is basically a polytropic process. It's a polytropic process, and you have immediately gauged what that power is. This is that power, -1. Now recollect our formulas. If I want to find the molar heat capacity, that means I need to write Q is equal to NC delta T. I have been asked how much is this C. Remember, Q by first law is delta U plus work. So let's find delta U as well as work, and then I'll get the next things. Delta U is always NCV delta T, standard formula. CV diatomic, that means 5R by 2 delta T. That's your delta U. Next, think work by formula is NR delta T divided by 1 minus that power which is there. That power is -1. Remember, NR delta T upon 1 minus that power exponent, whatever comes. So this will become NR delta T divided by 2. Work is known, delta U is also known. Let's use it over here, because I know by first law Q is delta U plus work is NC delta T. Delta U, just see, copy paste it, NR N5R delta T divided by 2, work NR delta T by 2 is equal to NC delta T. Delta T goes, N goes. So 5R by 2 plus R by 2 is a C. So C will be 5 plus 1, 6. 6R by 2. So C is 3R. That is the final answer. Yes, understood? Got it? My warriors, Akib, you are free to leave, bacha. I am not going to stop. You can definitely leave. Is that clear? Very, very important question, because this kind of question has come in JEE Mains multiple times. They give you some process and they ask you to find the heat capacity for that process. So the general way to find it is find delta U, find W, substitute it in the first law equation of heat. Automatically everything gets cancelled and you will get it. It's a very straightforward question. Okay, but this procedure you should know it. 3R is the answer. Last concept and last problem coming up on your screen, free expansion. Free expansion means you expand freely. There is no pressure, there is no tension, there is no loss, nothing. You take a gas chamber, let it out, open in air. That's it. It's a free expansion. There is no way to lose energy, there is no way to gain energy. The energy is conserved. That's it. That's called as free expansion. And let's solve a question on free expansion so that you get a hang of it. A container of volume, okay, this is the last question coming up on your screen. A container of volume 1 meter cube is divided into 2 equal compartments by a partition. One of these compartments contains ideal gas at 300 Kelvin. This is exactly like the previous diagram. You have a container divided into 2 parts. That guy contains gas at 300 Kelvin. The other compartment is vacuum, nothing is there. The whole system is thermally isolated from its surroundings. The partition is removed, the gas expands to occupy the whole volume. The temperature of the new thing will be, yes, like corona has no tension, free expansion, especially this new variant, Omicron, no tension. And even people are chilled out now. Omicron, hey, you got COVID, even I got COVID. Or oh my god, you got COVID, oh run away. Hey, even I got COVID, everybody's posting status because nothing much is happening. Yeah, it's less lethal and all of that. Very good, Arush. I hope you really understood it, because these are very important concepts, and trust me, these questions have been accumulated by our amazing content team so that you get the best learning outcome in these sessions. Specially designed for Nurture series, because the set of questions will be different when I do problem solving sessions in the sprint. Okay, yes. People are happy. What do we do? What is the answer? The answer is very simple. It is 300. Many people would have used some gas laws and God knows what. No need. Free expansion. I just told you, in free expansion, there is no exchange of energy inside or even outside. There is no where it can exchange. So if the energy remains the same, thermal energy remains the same, internal energy remains the same, delta T will become 0, temperature will remain the same. So temperature will be 300 Kelvin. That's why the answer is 300. Okay, so now here's the first homework question. You need to put up the answers in the comment section below. I will be checking it out. Post it as soon as possible. That will be a quick revision. Also give you the confidence that yes, you have mastered lecture 1 of thermodynamics. Next lecture will be laws in the second law, and basically your heat engines, refrigeration, efficiencies, and cyclic processes, all of that. This is your third homework question, and it's there on your screen, and of course the fourth homework question up on your screen as well. Now, if you're wondering where and all you can get my lectures, I'll show it to you right over here. I hope I can show it. Yes, there you go. Now, if you're watching this class right now, okay, when you go to playlist, right, it's very simple. Just go to playlist. You can see right over here KVPY preparation is there. So you can see physics preparation, maths preparation, chemistry preparation, everything is there. Essay, SX is there separate. Strategy and important tips, tricks sessions, formula revision session is there here. Pathfinder, that's for 12th, adults only. You're not yet adults, I'm guessing. Some of you are, if you're watching it from 12th or dropper point of view. All right, no problems. Nurture is for, yes, you guys, for you kids out here. So watch this. This is, okay, Nurture Physics. You can click on this and you can see the beautiful playlist arrives. Oh my God, what the hell is he doing? Please stop breaking his head. Okay, I cannot play this. No violence. Sorry guys. There we go. You see this playlist? Click on this. Okay, let's get this dude hitting with the hammer, the Thor guy, out of the screen. And there you go. Units and dimensions, everything. Circular motion, fluid mechanics, thermal physics, blah, 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 blah. Everything is there. Everything is there. Yep. Yeah, you can see that. Now, also, there is a Republic Day offer which is going on right now. I don't know how many of you know this, but yes, when you are watching this video right now, you will notice that the batch which is going to start, and it's going on for 11th standard revision, quick revision, one shots, live plus recorded, so many things like assignments, test series, complete 11th standard. It's going on. You can join it. And I'll tell you what's the best part. Okay. Oh, sorry, not this one. Not the JEE 2022. The 2 years. Click on this. The crash course, that's for adults. If you're not an adult, click on this. This is a 2-year course. Okay, there you go. You get KVPY, you get JEE preparation, board preparation, everything. Best part, you will enter into my batch of 12th standard. So if you want to get into my batch, English medium batch, of course. So go ahead, join it, because I'll be teaching only those students who will be coming from 11th to 12th. Not new 12th standard students, but 11th to 12th. So go ahead. There is a Republic Day offer of 50%, and when you use my coupon code, you saved 50% on the course price. So you're getting this course price for 750 rupees per month. Try it out for 1 month. You'll be like, sir, it's 15 days. Now, when you use my coupon code 15 plus 15, you get it for 1 month. That's how it is. Okay, crazy, right? So amazing offer for Republic Day, not long. Again, this offer will go off, and you know the standard discount is usually 10%, and you don't want to get 10%, you want to get 50% discount. 750, that's peanuts, nothing. Okay, so you have the higher packages too, and many students actually go for the classic version where you get doubt solving on the mobile app. And if you want personal mentorship, of course, you can go for the personal mentorship on the plus version. Try it out at least on light or classic. Either way, it's the same thing, same classes, just that you'll get doubt solving. That's an additional feature of classic. So try it out. It will be fun. So nice to see all of you out here for tuning in. Lovely, Monday evening, and thank you for watching till the end. And God bless you. Stay safe. And yes, go ahead, smash the like button. And thank you for also hitting the subscribe button. And let's grow, and let's study, and let's rock it. Okay. Consistency is the key. Stay tuned, because you have already stayed till here in the Nurture series. There's only one more chapter of waves which is remaining. Okay, so let's go to the last lecture of thermodynamics, probably day after tomorrow or on Thursday. Till then, have a safe stay at home. Take care of your family, study well, work hard, and God bless you. Take care. This was Shreyas here. Hasta la vista. Take care. Bye bye.